Hello again everyone, welcome back to ptet.chemistry channel. So this is a lecture tutorial as part of the series on stoichiometry and the mole concept. This is for the 5070 O-level chemistry, but the contents within are similar to any of these IGCSE chemistry, whether you are core extended students or any other 14 to 16 years old chemistry students, pure chemistry students all around the world who have found the contents highly similar. This includes the all-level students in countries like Singapore as well. Okay, so in this lecture tutorial, I'll specifically cover the relative atomic mass and relative molecular masses, and we'll think about how to use the periodic table to actually work out what is relative atomic mass, which I already did actually in the topic 2 on atomic structure, but we'll revisit that again. So this is abbreviated usually big A and small r as a subscript. It's not A and R on the same level because they will represent argon, which is an element, which is element number 18, a noble gas with a fully filled outer shell. So big A and the subscript R slightly lower below the horizontal level. Relative molecular mass, big M and small r. We did MR before when we talk about diffusion. So back in topic 1, that's our matter, we talk about diffusion, which relates to the MR of single molecules, and substance with lower MR will have lower relative molecular mass. It will be lighter, it will diffuse faster, and they will tell you which one will diffuse at a faster rate, and so on and so forth. So this is directly straight from the syllabus. These are just the learning objective. So as a student, as a candidate, you are sitting for exams, so students should be able to describe and define. You see here. So the first one is describe relative atomic mass. Is describe and not defined because this is a longer definition than this. This would typically come out as a 2-mark question because the first mark is typically this one. The average mass is to do with average because it's not an exact mass. If you look at chlorine in the periodic table, you have these things which are not international standard. This is from the periodic table where the numbers are given in the middle. So they give you the atomic number or the proton number in the middle on top, and then they give you the relative atomic mass. They never tell you it's mass number or nuclear number. They even tell you that it's relative atomic mass in the periodic table. So you know the relative atomic mass is not mass number because you know chlorine has 2 isotopes. There's your case study, chlorine 35 and chlorine 37. They are present in a 3:1 ratio. So it's like if you have a piece of cake, that means 3/4. This thing is going to be chlorine 35 because 3:1. If you cut into 4 slices, 3 slices would be chlorine 35 and 1 slice would be chlorine 37. As you can imagine, if you think about the averaging, if you have 35, if you have 37, if you have 50% of each, the average mass will be exactly in between, but this value is exactly in between there. So it's like you have slightly more of the 35 than the chlorine 37. That's why your average is closer to 35 than 37. They are not in a 1:1, meaning they are not in a 50% to 50%. This is actually 3 out of 4 out of 100%. This is 75%, and this is 25%. So when you take the ratio of 75%, 25%, you're going to get 3:1. I always remember the case study of chlorine 35 and chlorine 37 because it's a case study of how you work out the relative atomic mass, as I did in the atomic structure lecture tutorial about 2 or 3 topics ago. So you can review that and you can see in your notes as well. So it's a weighted average mass of the isotopes of an element, and it's compared to 1/12 of the mass of an atom of carbon-12. If you think about isotopes refer to different atoms of the same element. So they have the same proton number but different number of neutrons. Those are isotopes definition. Isotope refer to atom. So this is comparing an atom to an atom, but it's the average mass of the atom based on all the isotopes relative to the mass of an atom. N atom meaning one atom. So if you forget this one atom, then your ratio will not be the same. If you forget this 1/12, then your definition will be incomplete. This is usually a 2 marks definition. You don't want to give up on simple things like these, yet at the same time you do not want to memorize things that don't make sense to you. Okay. So next bit of definition is to do with relative molecular mass. Basically, if you know the definition of relative atomic mass, relative molecular mass is basically sum up. You can use sum, you can use total. It's the sum of the relative atomic masses, basically of all the elements present in the formula. For example, if you have Cl2, this is a molecule. Okay, these are atoms, this is a molecule, so it has relative molecular mass. So the sum of the individual relative atomic mass will be 35.5 is the relative atomic mass. So the MR of Cl2 will be 35.5 times 2, which is 71. And of course, for ionic compound, which do not exist as molecule, they can use this term called relative formula mass. The symbol is the same, Mr, but we don't call ionic compound as molecular because ionic compounds do not exist as single molecule. That's from your structure and bonding, also a couple of topics ago. All right. Now this is just basically an extension of that thing that was stated in the syllabus. Ratio of the average mass of one atom. You can say one atom or the mass of the isotopes of an element. I think if I were you, I'll probably go for the definition stated by the Cambridge syllabus. This is just another way of saying it, but it's got all the detail as well. It's got 1/12, the mass of an atom of carbon-12. Again, you should probably use the one that has isotopes in the definition, but the average is the key thing. So there's average, and there's the 1/12, there's the carbon-12 isotope, and it's the mass of one atom. Now you can forget about this relative isotopic mass. It is actually an AS level definition. So you know when we talk about each and individual isotope, these are the whole number, mass number. These are whole numbers that represent mass number or nucleon number. This number 35 or this number 37 is also known as relative isotopic mass, but that is actually not required by the syllabus, so you can forget about that. Relative molecular mass, MR, is the sum of the individual relative atomic masses, as we mentioned. And of course, for ionic compound, again, just to refresh your memory, ionic compounds don't exist as single molecule, so they use this term relative formula mass. But MR and MR are the same way of doing them. You calculate this relative formula mass the same way you calculate relative molecular mass. How many atoms do you have? And then you multiply by each and individual relative atomic mass from the periodic table, and then you sum them up. So what's important here? The molar mass of a substance is the mass of 1 mole. So 1 mole will make more sense to you probably in the next couple of lecture tutorials. Hence, since it's the mass for 1 mole, so it's the gram, the mass per mole, per 1 mole. So it's the mass for 1 mole of the substance. All right, so play around with the units, and the units never lie. The units will never disappoint you. Just need to be better at maths. Calculating relative molecular mass is the same method. It's just different names. These are for molecules, these are for ionic compounds, but both of them we abbreviate them as MR and we calculate them the same method. Okay. Only the relative isotopic mass is an exact number, and there's chlorine 35 or chlorine 37. Those are your case studies. So the chlorine 35 has a mass number of 35. That is the relative isotopic mass. But the relative atomic mass of chlorine is 35.5 because this is the average mass of the isotopes, which are chlorine 35 and chlorine 37, compared to 1/12 times the mass of an atom of carbon-12. As mentioned also, chlorine molecule, so this is Cl2, this is MR of Cl2, so that's why you have 35.5 times 2. Just at the space below there, I'm going to show you, or in fact, I'm going to just refresh your memory because I've already shown you before. So it's either you use the percentage or you can use the abundance ratio. So abundance ratio does not have a unit of percentage. These are percentage, these are expressed in terms of percentage out of 100%. So relative atomic mass is going to be the mass number times the abundance, so 35 times 3. And then you sum them together, 37 times 1 So what you're going to get then is you're going to divide that by 3 plus 1. So use bracket. Okay, so 35 times 3 plus 37 times 1. You're going to get 142. So 142 divided by 4. You are going to get 35.5. How about if you use the percentage? It's going to give you the exact same answer, except that at the bottom you don't have 3 plus 1, you will have percentage. So 35 times 75%, because that's the one that you have a lot more of. 37 times 25% divided by 75 plus 25%. So what you're going to end up with is 35 times 75 plus 37 times 25. You're going to get 3550 over 100%. And again, you get 35.5. So it's the exact same value, whether you use the percentage or whether you use the ratio of the average. The ratio, the isotopic abundance ratio. Okay, so this is the ratio. This is the abundance ratio, whereas at the bottom there, these are percentage abundance. Percentage has a unit of percentage. Abundance ratio does not have a unit at all because it's just ratio of numbers. And both of them works out the same way. So which method is correct? Both methods are correct. Which mistake that students often make is that they always think the bottom has to be 100. But then that is because you have 75 and 25. If you have 3 and 1, you sum up 3 plus 1 at the bottom. It's just as simple as that, and it's just mathematics. All right? So we have a few examples here of you having to calculate the MR for the following compounds. To do this, you should have a periodic table next to you so that you can refer to your periodic table easily. So for H2O, this means you have 2 hydrogen atoms. So the MR of H2O, typically we will write like this, MR and then bracket H2O, we will write 2 times 1 because there are 2 hydrogen atoms and each one has a relative atomic mass, or we say the AR of hydrogen given the periodic table is 1 and there are 2 hydrogen atoms, and we're going to sum up. You have 1 oxygen, each of which is 16, so that's going to give you 2 plus 16, which is 18. And for B, you have MR of NH3, so there is 1 nitrogen, so 1 times 14 plus 3 times 1 for the hydrogen. That's going to give you 17. For C, you have ethanol. So ethanol, methanol, ethanol. So those are part of your simple covalent molecule case study. They will make more sense when you come to organic chemistry. But you should be able to draw the display formula, and you should be able to draw dot and cross of these because you have done structure and bonding, and you know how many bond does carbon form, how many bond does hydrogen and oxygen form. So altogether, if you total up the number of carbon, you have 2 carbon. So I'm just going to do 2 times 12 because 12 is the relative atomic mass for 1 carbon. I'm going to sum that. I'm going to add that with how many hydrogen do I have? I have 3 hydrogen, 4, 5, and 6 hydrogen. So I can do 6 times 1, or I can do 1 times 6. It really does not matter because 6 times 1 is the same as 1 times 6. I also have 1 oxygen here. So there's 16 times 1. So press it into your calculator. 12 times 2 plus 6 times 1 plus 16 times 1. I get 46. Alright, so part D is sulfuric acid. Sulfuric acid is H2SO4. So you can get 1 times 2 for the hydrogen plus 32 times 1 for the sulfur. 16 times 4 for the oxygen. And press that into your calculator. So 2 plus 32 plus 16 times 4, you get 98. And turns out that I'm running out of space, but I'll just finish part E. There's hydrogen chloride, HCl. So the molecular mass of HCl. One of the most important case study is the calculating this and this. And remember the diffusion case study. Very, very popular in diffusion. So you can look back in topic 1 if you have struggled with this or not knowing how to calculate relative atomic mass before. So you need to be able to do this and not get confused at all. So part F is getting trickier because now you have ammonium sulfate Ammonium ion is NH4 plus, sulfate is SO4 minus. That's why you need 2 of the NH4 plus to balance out the charge of the SO4. If you can't get the correct formula from the name, that means you won't get the correct MR as well. This means there are 2 of these ammonium, so I'll put the 2 outside, multiply by whatever is inside. I have 14 times 1, because I only have 1 nitrogen. I have 4 hydrogen, so 4 times 1, close bracket, and now I'm outside, so there's 1 sulfur, so 1 times 32, plus 16 times 4, don't know why I can't write properly, and then do the thing inside the bracket first. Okay, so 14 times 1 is 14, plus 4 times 1 is 4, so there's 18. 18 is for the ammonium, 18 times 2, because I have 2 of this ammonium, so 18 times 2 give me 36, and then plus 32 times 1, plus 16 times 4, I get 132. Same thing with G, so you're gonna have ammonium I think I did that for G, so that's actually G, so I need to find a space there to do for F. So F is the simpler one, is NH4 NO3 ammonium nitrate. So altogether I can see there are 2 nitrogen, so there's 2 times 14. Altogether there's 4 hydrogen, so 4 times 1, and then I add together there are 3 oxygen, so 16 times 3 plus 4 times 1 plus 14 times 2, I get 80. Last but not least, part H looks scary looking, but it's actually not too bad. The dot means is hydrated because it has got water of crystallization. So these are called water of crystallization. They are actually part of a solid. They crystallize within as part of the solid. You will learn more about these. If we got dot H2O means there are 5 of these H2O. You need to add the MR of 5 H2O. So what we will get is the MR of CuSO4 dot 5H2O. That's the way we pronounce it. So there's 1 copper, so it's 1 times 64. And there's 1 sulfur, so 1 times 32. There's 4 oxygen, so 4 times 16. To be honest, you could do 64 times 1 or 32 times 1. It doesn't matter. It's just how many of the atoms you have multiplied by the relative atomic mass, and then the relative molecular mass or relative formula mass. Both of them have the same method of calculating them. So it's just adding up the individual masses depending on how many atoms you have. And then I have 5 because I have 5 of the water. So I use a big bracket to combine the 2 hydrogen, so 2 times 1 for the 2 hydrogen of water, and 16 times 1 for the 1 oxygen of water. I have 5 water molecules, so you could add that up together. Let me just divide that. You just press all that into your calculator. So 64 times 1 is 64, plus 32 times 1 plus 16 times 4, I get 160. So 160 is for all of these. Then I do plus 5 times bracket 2 plus 16, so I get 5 times 18, and then altogether my relative molecular mass, my MR, is going to be 250 for that. Okay, now moving on to the next example. So this is well, it's kind of similar, apart from it looks scary looking, but we have 2 of this whole thing and we have a 2 of this thing, so be very careful. First of all, we have this thing inside the small square bracket. We have 2 of them, so you have 2 of them, and then out of the whole big bracket, if I use another color, you can see that there are 2 of the whole thing, and then I have 1 of these copper 2 hydroxide. Copper 2 hydroxide, because hydroxide is OH minus. If you have 2 of the OH minus, meaning you have OH minus the whole thing, 2 of them, so it must mean you have copper 2 plus, so copper 2 hydroxide. This is a hydrated compound. It's a mixture of 2 compounds. It's hydrated salt. We are asked to find the value of X in this formula. So it has a MR. MR here refers to as relative formula mass because these are ionic compounds. Doesn't matter. So we know 552 is the total molecular mass. So I'm going to add up each and every one of them. So if I just do the XH2O first of all, so I have X number of water, So 1 times 2 for the hydrogen, 1 times 16. So I say it could be the number of atoms multiplied by the relative atomic mass, or it could be the relative atomic mass multiplied by the number of atoms. It really doesn't matter which way around you do it, as long as you have the correct multiple of atoms, and then you add them up together, and you have X molecule of H2O, so it's X times 18. I'm going to work this out with this simpler one first. So copper to hydroxide from your periodic table. So you have copper, which is 1 times 64, plus I have 2 times 16 for the oxygen. So I have another bracket. So there's 16 times 1 plus 1 times 1. So there is the hydroxide, OH, 1 oxygen, 1 hydrogen, multiplied by 2 because copper 2 hydroxide, and plus 1 copper, so another big bracket there. And now this is a scary looking one. There's a 2 of the whole thing, so I put the 2 outside first, and then big bracket inside. I have 1 copper, so it's 1 times 64. So this thing is about bookkeeping, and inside there is 2 times this whole thing. Inside this whole thing, inside the bracket, I have 2 of these CH3CO2, so it's 2 times. Now inside this green color thing, if I use green color now, what do I have? I have how many carbon? I have 1 carbon, 2 carbon, so I have 2 times 12. How many hydrogen? I have 3 hydrogen total, so there's 3 times 1. And then how many oxygen do I have? I have 2 oxygen, so I have 2 times 16. So that is inside this bracket, and I already have that multiplied by 2 because of the 2 here. So this 2 here refers to 2 times this whole thing inside the square bracket, plus the 1 copper, and then this another 2 outside because 2 times the whole sum of it. So essentially it's just a bookkeeping. It looks scary looking, but it's bookkeeping. So do the thing inside the bracket first. 16 plus 2 is 18, so it's 18x. And then I do the second bracket, which is 64 times 1 plus 2 times 17. So 16 plus 1 is 17, times 2 is 34, plus 64 is 98. Now instead of trying to make my life complicated, I'll do whatever is inside here first before I multiply the 2 outside. So I just put the 2 here outside. I'll do all of these in this bracket. 64 plus 2 times, bracket 2 times 12, plus 3 times 1, plus 16 times 2. I get 182. As with anything that looks complicated, I'll double check my calculation. So this time I'll do the thing inside the bracket first. So 2 times 12, plus 3 times 1, plus 16 times 2. I get 59. 59 is all of this green thing, times by 2. I get 118, plus 64 times 1. What have I done? So times 2 is 118 plus 64. I get 182. You see, I think I've done a mistake already. I think 182 is after I multiply by 2 already. So let me just double check my calculation again, just to be sure. Inside this bracket, I have 2 times 12 plus 3 times 1 plus 16 times 2. I multiply by 2, I get 118. 118 plus 64. Oh, this thing is 182, so I was right. So it was 182. 182 is this thing. So 2 outside is still there. So what I could do now is I could sum up 98 plus 2 times 182. So 182 times 2 plus 98. This gives me 462. So 18x is equal to 552 minus 462. So what can I say? X is going to be something divided by 18. So 552 minus 462, I get 90. And that is a perfect whole number of 5. So x is a whole number. Even though you get a decimal place, you have to round it up to the nearest whole number. Okay? So yeah, I think I'll just leave it there for these lecture tutorials. I've shown you a couple of examples, basically on the meaning of relative molecular masses in terms of summing out the individual relative atomic masses. I talk about the importance of actually knowing definitions, as Cambridge like to talk about and ask about this kind of thing, very specific thing, and the very kind of thing that a lot of students would actually, kind of like waffle along, or like don't really care so much about it. But when it comes up, you can't blame Cambridge, because Cambridge said candidates should be able to is from the syllabus. If you do a topical syllabus checklist, you know what I'm talking about, where we just spend the last the last bit of the lecture tutorials just calculating MR, just being careful with bookkeeping. And you might be very good at pressing calculator, but if you can't show your working, sometimes you can make mistakes if you can't do bookkeeping like this. Alright, so I'll leave it there for these lecture tutorials, and I'll see you guys in the next lecture tutorial. Thank you for watching. Don't forget to click the button on the bottom right to subscribe to the channel, and please share the channel widely with all your friends, chat and study groups, juniors and seniors from school, what else, relative, and yeah, follow me at ptet.chemistry. There's ptet.chemistry to get connected, and yeah, just to get acquainted, I guess, and send in your queries and stuff. Alright, so thank you for watching again.